Good morning. This is your stats sensei, Mr. Spensei, and this is reviewing the normal, the binomial, and geometric. This will be video part one of that review, and we'll cover questions A through G. So a company that manufactures smartphones developed a new battery that has a longer lifespan than that of the traditional battery. From the data purchase of a smartphone, the distribution of the lifespan of the new battery is approximately normal. That's good because that means I can use central limit theorem for any sample size with a mean of 30 months and a standard deviation of 8 months. All right, I'm gonna go ahead and draw this off to the side so I don't forget about it. So we have a mean of 30 and we have a standard deviation of 8. For the price of $50, the company offers a 2-year warranty on the new battery for customers who purchase the smartphone. The warranty guarantees the smartphone will be replaced at no cost to the customer if the battery no longer works within 24 months. So if we end up down here at 24 months, the battery is replaced. All right. So what is the probability that a randomly selected battery from the company lasts between 25 and 30 months? So we want the probability that 25 is less than X is less than 31. I'm going to say let X equal the battery life. Now, really, it's the battery life in months. I probably should write that out, but due to the interest of space, I won't. So, in this case, we want to know what's the probability that it's somewhere between 25 and 31. That's what we're looking for, that area right there. All right. And we know that they do replacement after 20, anything less than 24 months. So, and please remember this goes from negative infinity to positive infinity. So I'm going to need to set up using a Z formula. And remember, Z equals X minus mu over sigma. So I want the probability that, you know what, I'm going to do that right here. Probability that Z is less than, we always start with a higher. So 31 minus our mean of 30 over standard deviation of 8, minus the probability that Z is less than 25 minus 30 over standard deviation of 8. And we're going to go do a stat test Z test. So stat test Z test, mean of 30, standard deviation of 8. We're going to start off with a higher one, which was 31. And our sample size, we said a randomly selected battery. Remember, A means 1, so we're working with a sample size of 1 in this case. And we end up with a z-score of 0.125. So the probability that z is less than 0.125 equals 0.549. And that makes sense because it makes sense to have that being greater than 50% because that's over halfway. So 0.5497. Now I'm going to have to do it for the other one. So I'm going to go stat test z test and z test. And the only thing I'm going to need to change in that is my x is no longer 31. It's the lower bound of 25. And I end up getting a z-score of negative point. So the probability that z is less than negative 0.625, and that happens to equal 0.2659. When I subtract those values, 0.5497 minus 0.2659, I end up getting 0.2838. I'm going to pause this for a moment and see if I can't get a little better lighting in here. All right, the next one says, suppose one customer who purchases the battery, purchases the warranty is selected at random. What's the probability that the customer selected will require a replacement within 24 months of the date of the purchase because the battery no longer works? All right, so in this particular case, we're still working with the same um, graph of 30, but we want to know the probability that's less than 24. So we're looking at this, and remember that goes to negative infinity. We've defined X up here, probability that X equals the battery life in months. So we want, in this case, the probability that X is less than 24. So that's going to be the probability that Z is less than 24 minus my mean of 30 over my standard deviation of 8. Stat test Z test. Mean of 30, standard deviation. I just need to change that X to 24. Calculate. And I find out that I have a Z score. Probability that Z is less than negative 0.75 equals 0.2266. So about a 23% chance. All right. The next one. In about how many months from the date of purchase is it expected that 25% of the batteries will no longer work? Justify your answer. All right. So once again, we're going to draw our graph. We know that our mean is 30. We'll sit there here. And this time they gave me a percentage. Well, if they give you a percentage or an area or a probability, I'm going to have to use inverse norm because I want to know what this value is. All right. They want to know how many months. So I don't know how many months it is. So let X equal the number of months. All right. Well, if I set up my formula and then go, okay, well, Z equals X minus mu over sigma, let's look and find out what we have. Well, what I have is I don't have the X. I do have my mean. I do have my standard deviation, and I don't have my Z score. All right, because our formula is Z equals X minus mu over sigma, and I don't have a Z score, but I can get that Z score by doing an inverse norm. So second vars, inverse norm, area is 0.25. Remember, all Z scores have a mean of 0, standard deviation of 1. We are coming from the left. Press enter. And we end up getting negative 0.6744. All right, now I can solve this by algebra or I can shortcut this. I have to have that Z-score for College Board, but I can shortcut this instead of solving by algebra and go second vars, go back into second vars inverse norm, keep my area the same. That's that same here, but let's use our actual mean and our actual standard deviation. And I should get a number less than 25. So 25% of the batteries quit working in about 24.6 months. So in this case, X equals 24.604 months. All right, D. The company has a gain of $50 for each customer who purchased a warranty but does not require replacement. So if it lasts more than 24 months, we don't have to worry about it. They're going to make 50 bucks because that's what they're selling it for. The company has a loss, a negative gain of $150 for each customer who had purchased a warranty and does not require a replacement. What is the expected value of the gain for the company for each warranty purchased? Well, I need to know what percent of the batteries last less than 24 months. Well, we actually calculated that earlier. We basically said 24%. We said in part B, we said 22.66 batteries lasts less than 24 months. That's what we calculated here. So if I take that 0.22 or 1 minus that 0.2266, that tells me how many last longer than 24 months, and I have a gain of $50. All right, but I have a loss 22% of the time, and that loss costs me $150. So let's do this real quickly. 1 minus 0.2266 and times $50. So I end up making $30. I expect to make $38.67 most of the time. But I also have a loss. And that loss is 0.2266 times 150. So minus $33.99. So when I subtract those two, I end up getting the 38.67 minus the 33.99. I end up making, we expect to make, our expected is $4.68. So I expect to make $4.68 for every phone I sell with this new battery. Again, or if I sell that warranty. Again, 22% is how often we expect to have to pay out, and we have to pay out $150. 1 minus that is what we expect when we expect not to pay out. So I expect to pay out this much. I expect to have that gain that amount of the time. All right, the next one. In how many months from the date of purchase is expected 95% of the batteries will no longer work? So let's go ahead and draw our picture here. And our picture looks like this. 30 months. And this area right here is 0.95. All right. So remember, Z equals X minus mu over sigma. All right. And we're looking for this X. Let X equal the number of months. So in this case, we have the, we start plugging in what we have. I go, okay, well, I'm looking for X. I don't know that. I know my number of months is 30, and I know I have a standard deviation of 8 from above, but I don't have this 95. I don't have the Z-score, but I can get that by doing an inverse norm. And remember, there's really no work to show on that. So second vars, inverse norm, 0.95. All Z-scores have a mean of 0, standard deviation of 1. We're coming from the left. And we end up getting 1.6448. All right. Now I can solve that by algebra, or I can go back into inverse norm and start putting in the actual values for the mean and standard deviation. So second vars, inverse norm. My mean was 30. My standard deviation is 8. And I better get a number over 30 because we have 95%, which is over halfway. And sure enough, it takes about 43 months. So X equals 43.1588 months. All right. Next one. What percent of the batteries no longer work after 36 months? So let's draw a picture of that. So our picture is going to look like this. We have a mean of 30. This is 36. And we're looking for this area. So we want the probability that X, the number of months, is less than or equal to 36. So once again, we're plugging into our Z formula. When we do that, we have the probability that Z is less than 36 minus our mean of 30 over a standard deviation of 8. Stat test, Z test. Mean of 30, this is standard deviation of 8. 36, we're only looking for we're looking for the percentage. And we have the probability that Z is less than 0.75 equaling 0.7733. All right, so this is my answer right here, about 77%. What percent of the batteries will work between 24 and 30 months? Let's go ahead and draw that picture. So my picture is going to look like this. Well, we have a mean of 30, and we're looking for 24 here. Well, that's very interesting. Well, I know that 30 is 50%, so I really don't have to solve that, but I'm going to. But I know 30 is going to be 50%. So in this case, we're looking for the probability that 24 is less than or equal to X is less than or equal to 30. And like I said, that's 30 is right in the middle. So really, or at the mean. So I don't really have to do it, but I'm going to. So I have the probability that Z is less than 30 minus 30, because we always start with a larger number, over 8, minus the probability that Z is less than 24 minus 30 over 8. And so I'm going to go run a Z test twice. Stat test Z test. Change that X to a 30. That's the only thing that changed. And told you our Z is 0 and our probability is 0.5. So the probability that Z is less than 0 is 0.50. And then I need to do the same thing for the other value for 24 months. So stat test, I need to change my X to 24, keeping the mean at 30, standard deviation of 8. And I get 2266. And I have a Z of negative 0.75. So the probability that Z is less than negative 0.75 minus, and this is right here, is 0.2266. When I subtract those, 0.5 minus 0.2266, I find out that the difference is 27%. So about 27% lasts between 24 and 30 months. So 0.2734. So this is a review of the normal. Hope you enjoyed it. I look forward to seeing you on the next one when we talk about the binomial, geometric, and central limit theorem. Thanks for watching. See you on the next one.